Hi there. Today in this video we're going to be going over derivatives of parametric equations. So for this you're going to need to know the chain rule for derivatives and of course what parametric equations are, which is right here. I don't have a video more explicitly going into them, but I may, and when I do I will link it in the description. But parametric equations, I'll just go back down, are this here, where we have, instead of f of x equals y, so instead of this, it's these two things, where we have some function with t in instead of x, and that equals x. Then we have another that equals y. And then you would plug various values in for t to find x and y, and that's how you would graph something. Anyway, we're going to start with basically what I wrote down there with that, with parametric equations. F of x equals y, g of t equals x, and h of t equals y. Now, if we take this and plug in these two for x and y, that gets us f of g of t equals h of t. Now, just as it is, if we took the derivative of both sides, which is taking the derivative of the same thing, so f prime of x equals y prime, that would get us f prime of g of t, there we are, and then using the chain rule, that f prime g of t times g prime of t equals h prime of t. Now if we use algebra to move stuff around, specifically we move this g prime of t to the other side of the equation, that gets us f prime of g of t equals h prime of t over g prime of t. Now we know g of t is actually x, so that we can rewrite this again as f prime of x equals h prime of t over g prime of t. And we already mentioned that f prime of x is y prime, so that's what we're looking for. We're looking for f prime of x, dy dx. Well, that's what this is. So that's where this comes from, but we can rewrite this, of course, as f prime of x being dy over dx equals well, no, we're going to rewrite those as well. Dy over dt, because h prime of t, we're trying to find derivative with respect to t. So dy dt over dx dt. Now that's that. That is the first derivative. But this is going to also cover the second derivative. So another way of rewriting this again is d dx of y. So d dx, or the derivative of y, equals the derivative of y with respect to x, I should say. And then derivative of y with respect to d over derivative of x with respect to t. So that's another way of rewriting this here. So, in this instance, we're taking the derivative of y, which is what we want, but if we're taking the second derivative, we want the derivative of dy dx. So if we want to take the derivative of that, we just replace, whatever we want to take the derivative of, I should say, we replace with y. So if we wanted to take the derivative of some constant for some reason, that would be 0. But if we wanted to, it would be d dx of a constant equals d dt of that constant over d dt of x. But that would be 0. But with the second derivative, that becomes d dx of dy over dt, dx, excuse me, dy dx equals d dt dy dx over, and this just stays the same since we're not replacing the x, d dt of x. So let me just write f prime prime of x. So that's the second derivative here. Second derivative. This is a little messy, I guess, but hopefully it helped and explained how we get these formulas here for the derivatives of parametric equations. Like I mentioned, I don't have a more general video on parametric equations, but I may get that up, and if I do, it will be in the description. Hopefully this helped, and I will see you in the next video.